Hey YouTube, it's been a while since I've posted an engineering project. There's been a weird turn of events, but I believe that this next project that I'm doing, it'll be pretty unique. So I hope you guys enjoy the next couple videos that'll be coming. So for my entire life, I've been a fidgeter, whether I'm at school, at the house, anywhere. I can easily spend 30 minutes out of my day bouncing my leg, spinning in my chair, twiddling my thumb, just anything that isn't productive in general is fair game for me. Hence the name, the Dongling Engineer. Anyway, the COVID-19 pandemic has flipped this entire last quarter semester on its head. Any projects that were scheduled during this time have been canceled, except for our end of the year project of choice. This project is based off of our passion, and since I can't disturb the peace of the neighbors, I've turned to tackling my fidgeting problem with the power of electricity. Let's get started. No, I'm not going to make an anti-fidget device that shocks me every time I get off task. I'm making my fidgeting useful in this project by turning the energy that I waste by bouncing my leg up and down into electricity to power my lights, phone, and other projects. After some research, I came up with two sources for me to test: piezoelectricity and an AC generator to implement into a design. I started with the easiest of the two to draw, the piezoelectric device. The concept for this design will work similar to that of a drum set, where the bouncing of my foot will press the top of my device down. That downward force will then hit a piezoelectric striker to generate electricity that will either be stepped up or down to match the voltage and current of a standard North American outlet. Drawing the concept was relatively simple. However, I needed to test out this theory to see if the concept was viable. I started out by trying to make my own piezoelectric striker with quartz, pennies, and some pliers. However, I was only able to squeeze just enough electricity for my voltmeter to detect. I upgraded to a pre-made striker salvaged from a gas lighter and was able to see arcs jump from the device when pressed down. This seemed promising. However, when it came time to make a light circuit for it to power, it barely lit the tiny 3-volt light if it wasn't shocking me. And even the shocks were less painful than if I were to receive a static shock from rubbing my socks against carpet or a trampoline. Fortunately, the design that I drew up is not limited to just a piezoelectric system. Rather, it is designed around my foot in the size of a typical North American outlet setup at just a little over 4 inches wide, under 3 inches tall, and around 10.2 inches long. If I can't find a piezoelectric source that can supply more electricity, especially current, I might have to move on and utilize an AC electric generator. It would be more moving parts to transfer the vertical motion of my foot into rotating motion for the generator. However, this may be the better route to get the results I want. I hope you enjoyed this video. Please continue to leave a like, comment, and subscribe if you have not done so already. This channel is an engineering project in itself and needs your support to continue putting out content. Depending on how the rest of the COVID-19 crisis continues to affect the schoolwork schedule, I should be able to release a video once a week on this project. I hope that everyone is taking the necessary precautions to stay safe and healthy in this crazy time we find ourselves in. Don't forget to look in the description below. I have provided a link to a virtual race to keep people active and to support veterans. So this is an awesome cause, and the more people that participate in this event, the more help that these veterans who have been scarred for life really get to recover. So I hope you all stay safe, healthy, and I will see you all next week.